Okay, let's start. So hello, a very warm welcome to all of you. So for those whom I've not had the pleasure of meeting yet, I'm Anna Henken. I'm one of the new lecturers in the department. So just a few things before we get started properly. So this lecture is being recorded, and also please remember to kindly mute your microphones throughout. There will be ample time for questions and answers session of that at the end. So please do submit your questions in the chat and we'll read them out later. So now I'm delighted to be introducing the very first lecture of this year's distinguished seminar series. So here with us is Allison Godwin, who's an associate professor in engineering education at Purdue University in the United States. So Allison is also the Workforce Development Director for the Center of Innovative and Strategic Transformation of Alkane Resources. And this is a National Science Foundation engineering research center in the States. Allison's research group is called STRIDE, which stands for Shaping Transformative Research on Identity and Diversity in Engineering. And the group works towards understanding identity development of diverse engineering students, so how they come to choose to study engineering and persevere in their studies. And Allison also studies how different experiences within the practice and culture of engineering, how they can foster or hinder belongingness and identity development. Allison's research earned her a National Science Foundation Career Award, and this is focused on characterizing latent diversity, which includes diverse attitudes, mindsets, and approaches to learning to understand engineering students' identity development. So Allison has won other multiple honors and awards for her research, and these include the IEEE Frontiers in Education Benjamin J. Dasher Award in 2017, the Purdue University College of Engineering Exceptional Early Career Teaching Award in 2018. Then in 2020, Best Diversity Paper Award in Educational Research and Methods Division of the American Society of Engineering Education. And Allison was also invited as a participant in 2016 to the National Academy of Engineering Frontiers of Engineering Education Symposium. So this is just a selection of some of Allison's achievements. And today, Allison will be talking about the evolution of a materials and energy balance course, designing for student motivation and success. Over to you, Allison. Thank you for joining.
Wonderful. And thank you for that very kind introduction. I'm really looking forward to talking a little bit more about an ongoing project that has been in the works since spring of 2018, and tell you about changes we've made to a second year materials and energy balances course at Purdue University in the States, and maybe some suggestions that might be helpful for considering engineering education changes in your own teaching. So you already know who I am, but I'll tell you a little bit more about my journey, because I think there's a bit of a unique pathway into engineering education and then back to chemical engineering that brought me to this work. So my bachelor's degree is in chemical engineering. I went to Clemson University in the United States, and after graduating, I spent a short period of time working in a pharmaceutical company manufacturing active ingredients for mostly oncology drugs. And that was a great experience. I saw the application of my undergraduate degree in an engineering context, but I started to think about what I wanted to do for the rest of my life. And I'm not sure that the industry application was really what I wanted to do. And so I actually started exploring going back to graduate school. And I went back to Clemson University. At the time, it was one of 4 engineering education programs in the United States, and earned my bachelor's degree in engineering and science education. After that, I joined Purdue, which is one of the other oldest engineering education programs, and formed the research group that we talked about a little bit earlier, STRIDE. And then you heard a little bit about my career award as well. This is a great launching point as an early career researcher and a national recognition for research that really launched the opportunity to not only study students' identity development and other underlying attitudes, beliefs, and mindsets in engineering, but also to consider what are the implications of those attitudes, beliefs, and mindsets in the context of education, and working with faculty to think about the changes that they might make to support those students in their classroom. And so through that, I began to work with chemical engineering at Purdue, and over the last couple of years have moved into an administrative role with the center that you heard about, C-STAR, but also recently was joint appointed into the department. And so as a workforce development director, I do a wide range of things from K-12 or pre-college outreach to graduate student professional development. And I'm also now an assistant editor with chemical engineering education. So I have the opportunity to not only do my own research in chemical engineering education, but to see the scholarship of others being published in that space. And so with that, I come to the space of thinking about education. And so one of the things that drives me is we've seen dramatic changes and advances in engineering. Why has education predominantly remained the same? So these are two pictures of college or university classrooms taken about 60 years apart, and they look pretty much the same. We've got furniture oriented to the front of the room. You can't see the instructor in the second picture, but the instructor's at the front, not writing on a chalkboard, but in this case, presenting on overhead projectors and using the dot cam. And so I'll reveal kind of where these pictures come from. They come from our institutions. And I don't know what the university college classroom looked like at Imperial at this point, but this was taken just a few years ago at Purdue for the 2017 picture in our sophomore materials and energy balances course. And so, I raised that question both, I'd be interested in your input if you want to chat about that at the end, but also rhetorically, right, there are some documented challenges in the literature why curriculum reform is so difficult and why teaching has predominantly remained the same. And some of the challenges probably will resonate with your experiences. It takes time to do this kind of work. It's difficult with all of the other demands that we have on our time as academics. It takes some training and knowledge of evidence-based practices in the literature. Again, if this is not your background and training, that's an extra workload of learning more about what exists in the literature or through workshops or seminars. There has been some documented student resistance. When you change the system that they've learned to excel in, sometimes there's pushback from students that this is not what they want. Often institutions don't value or reward those efforts. And it takes time and money. So the resources beyond time that are needed to be dedicated to that are also a factor in playing out whether or not educational reform happens. But I would argue, particularly from my positionality, that there are some really important benefits. And so we've seen deeper student learning outcomes, more inclusive classrooms, which is directly relevant to the kind of work that I do. And I want to say, once the front end effort is put in, the preparation after that is actually often simpler because the classroom time is not completely focused on the instructor and the notes and materials that they have prepared, but actually engaging the students in co-constructing that learning environment. But when I think about educational change and where the levers are and where we approach this work, it's a complex system, which I think also adds to the challenges of curriculum reform. And so I have a brain, for a lack of a better representation of a student's learning environment, but it's not just about cognition or what students are learning or the content of the course. Those are things that you could change and they're important, but those also pull on other important pieces like students' behavior. Are they showing up to class? Are they engaging in the study supports that you're giving them? Are they working with their peers to learn more outside of what you see in the classroom? And their affect, so their motivation, their interest, their excitement or not about learning, and all that's shaped by the context that you can set in a classroom. And so, while I think a lot of curriculum reform often focuses on the cognition or behavioral components, a lot of my work is really focused on that affective piece and how those things are intertwined. And so from that perspective, I'll kind of unpack some of the things we've been thinking about in the second year materials and energy balances course. So I want to tell you a little bit about the background of the course before I start talking about the changes that we've made. So the course is titled Chemi 205, Chemical Engineering Tools. It is a second year required course for students at Purdue University, and it is a 4 credit hour course. So it's our normal course load is a 3 credit hour per each course. So this is a little bit higher or heavier. And it includes about 200 minutes of contact time per week. At Purdue, we admit students to a first-year engineering program. Anyone interested in engineering comes to a general program that's very interdisciplinary. They do a lot of their math and science prerequisites, most of what your students do prior to showing up at the university. And then at their second year, they transition into their major and take their first course sequences in their particular discipline. So this is the first course in the chemical engineering curriculum after that first year experience. The focus is on materials and energy balances, and we see kind of various student populations who engage with the course. The on semester or typical time in which students take the course in their plan of study is in the fall. So we have about 160 students, sometimes up to 200, depending on the class sizes that we have matriculating each year in the fall. The spring enrollment is our off semester offering. It often brings in students who were on an industrial experience in the fall, as well as students who've had to retake the course. So it's a really different student population that's showing up in the spring. And similarly in the summer, we have a much smaller group taking it over the summer, but many of them are repeating students or students who are away on co-op, or students who've transferred into the university and are taking the class to get up to speed for their third year in the program. We use in the United States, I don't know what the common text is in the UK, but we use the Felder, Rousseau, and Bullard textbook. It's the textbook I learned materials and energy balances from, not the 4th edition, but a much earlier edition. And a good chunk of the programs in the United States use this text. And most of the class credit comes from in-class exams. So 3 one-hour exams and a final exam make up 85% of the course assessment. There are weekly homeworks that are turned in and get feedback, and there's a recitation where engagement and participation counts for 2% of the grade. And I think one of the challenges and why we kind of focused on this course in the curriculum to start to think about where changes could be made was a 2-pronged problem. First, we had high rates of failure in the course. So earning a D or an F as a grade in the course, or students who had withdrawn from the course. And this was when you hit at least halfway through the semester point, students who no longer want to take the course can withdraw, but a W is recorded on their transcript. Both of these outcomes, which we call the DFW rate collectively, indicate that the student will have to retake the course in order to progress in their degree program. And if you look at the figure below, I've shown the historical data for the fall and spring semesters, since those tend to be the higher enrollment semesters. And our average DFW rate is 24%, has been historically. So about 1 in 4 students don't pass the course each time the course is offered, which is pretty significant. The other thing that was shaping some of the context of the decisions we were making, that there was a high change of degree objective, or we call this CODO, where students are leaving chemical engineering for another program. And so from 2010 to 2016, when the last report was done, about 12.5% of students left the program. And this number is a lot higher than our other engineering programs in the college. And when we looked at the rates of leaving by both race and gender, one of the things that stood out was the number of women who were leaving were similar to the number of men. But when we looked at the representation in our enrolled programs, that proportion, because women are traditionally underrepresented, was higher for women. And so this seems to be some sort of not only effect of student success overall, but a disproportionate effect for traditionally underrepresented students in engineering. And so in this context, we started to say, what changes might we make to improve student success outcomes within the course? So the course wasn't redevelopment free when I joined. And I think this experience and background set a stage for a really positive set of change. So I want to acknowledge where we started from when I started working with a team in 2018. The course had been through a program at Purdue called IMPACT, which stands for Instruction Matters, Purdue Academic Course Transformation. And this is run by our Center for Instructional Excellence. What it does is it creates an opportunity for faculty to rethink their course in light of best practices in the educational literature. So it engages a faculty learning community of people who are redesigning their course all at the same time and learning concepts together. They meet monthly to talk about the ideas they're learning, the changes they're making, and to create a supportive network to learn from each other and support the changes in the classroom. It also includes funds to small amount to support the course redesign and development for faculty time and any supplies needed. It engages instructional designers whose expertise and full-time jobs are to improve the content and structure of courses at the university. And it uses two pieces from the literature. One is student-centered teaching, which is shifting the focus of the classroom from the knowledgeable instructor at the front of the room who's disseminating knowledge to students to a student-centered model that often includes things like student-guided inquiry, problem-based learning, and other kinds of engagement, as well as a motivation theory, which I'll talk more about in subsequent slides, self-determination theory. So when I stepped into working with chemical engineering, the classrooms were already partially flipped, where students were being asked to watch 5 to 10 minute videos of the key content and definitions before class. And then about every 2 weeks, there was an entire 50-minute class period devoted to problem solving and modeling problem solving for students. And so I already stepped into a space in which some of this, I think, content was already created in a way that created the opportunities for additional and innovative thinking about what the course could look like. And I think the other piece that created a climate that was really ripe for change was that the instructors who had been engaged with the course had already engaged with the literature and education and the scholarship of teaching and learning. They had a high value for that. And when I made suggestions or cited literature, they valued those suggestions and contributions and were willing to let that guide decision-making in the change effort. So despite the I think, incredible value of impact, when we look at when it was introduced in fall of 2015 and the subsequent effect on student success in the course, we didn't really see much change. There's a bit of a dip in fall of 2016, but I would mostly attribute that to an instructor level effect rather than, I think, significant positive changes in the course. And as you can see, the subsequent semesters, right, it goes right back up to the normal DFW rates that we've seen historically. So that's where my engagement with the course starts. I met my collaborator and co-instructor, Professor Brian Baduris, in fall of 2017. And we started getting talking about ideas for this course and got excited about an opportunity to share best practices across chemical engineering and my home department, engineering education, which is responsible for the first year engineering experience and teaches approximately 22 to 2,500 first year engineering students a year. So we applied for and spent the spring semester in the faculty exchange program, which engages disciplinary faculty from across the college in our first year engineering experience. Brian co-taught with me in our course, and we created the design project in that course to focus on chemical engineering and a hands-on optimization project for reactions. And I got to co-teach with him in 205, the materials and energy balances course. And we had some conversations about best practices implemented there and also maintain the structure that they had in the past with impact. Brian is an award-winning teacher. He won the College of Engineering Early Career Teaching Award a few years prior to me, and I won it in a subsequent semester. And so, you know, we thought all signs point to good that we were going to be super successful in teaching Chemi 205 and maybe reducing some of the problems in success rates that we had seen. I'll give away the spoiler. We weren't that successful. So we thought, well, in fall of 2018, we'll redevelop the course again and we'll do something different. And that's what I'm going to talk about today as one of the first studies. And we re-instructed the course in the spring and did some measurement to understand the effects of our changes on students. And what we saw was not only consistent positive outcomes for our course and what we instructed, but in subsequent semesters, particularly fall of 2019 prior to COVID, a different instructor had the same kinds of consistent positive outcomes. And before the COVID-19 pandemic, we thought, cool, we'll continue to track this data and see if we've made the change over time, irrespective of who was teaching the course. Of course, the COVID-19 pandemic has happened, and so I'm going to present a little bit of the research that we've been doing since then, with major changes to the course and moving to emergency virtual teaching as well as asynchronous online teaching in the fall. Ara Adamarola is a PhD student who's been working on this, and she was gracious enough to help me with some of the data analysis and visual representations I'll present at the latter half of the presentation. But at the same time, we were also awarded a National Science Foundation grant to look at resource development within the course, particularly building on successes that we had seen in mechanical engineering at Purdue University. And we looked at the effects then of COVID on student motivation and stress this past fall semester. And so I'll talk about these in two different studies, but to give you the timeline of like all the changes we've been engaged with since almost 3 years ago now, we have the kind of traditional teaching structure and in-person engagement and changes made there, but we also have a piece of the virtual environment in COVID-19 that I have some insights or things that have changed since then. So I'll tell you first about study one. As I mentioned, we weren't that successful in co-instructing and seeing any change in student success, despite being award-winning teachers and despite following the impact best practices and partially flipped classroom, our DFW rates looked just like everyone else's. So doing business as usual didn't result in any change. So we decided to engage in this radical course redesign, and we were guided by 3 pieces in the literature that I think are important. First was we focused on what has been termed in the United States the sophomore slump. In that second year of the 4-year undergraduate education process, students often experience less satisfaction with the university experience. When they transition into their core disciplinary courses, they see increased difficulty in the content, and often the study strategies that they've used to date have not been particularly effective in being successful. So they have to learn new study strategies in addition to learning difficult content. And this is, in the US, often the point in which students leave engineering. About 50% of students nationally leave engineering, often by the end of the second year. We engaged active student-centered learning. This figure A and B on the bottom are from a proceeding of the National Academies of Science. And it's a meta-analysis of active learning and student-centered learning efforts in courses around science, engineering, and mathematics, so most of the STEM spaces. And we see consistent data that the percent of students who fail courses when you switch from a lecture-based to active learning environment is lower. So with the goal of reducing students who fail the class, we said, well, we definitely need to engage this much more in the way we think about course redesign. And finally, this is really coming from my work that looks much more at that affective piece. We really focused in on motivation. And we focused on self-determination theory because the impact program had used that. And studies have started to show that those non-traditional approaches to teaching, like active and student-centered learning, also have a significant impact on student motivation. So thinking about not only cognition and behavior, but how that's linked to affect in a context, these all seem like ripe pieces to pull together to be successful. And so this self-determination index, or an index of student motivation shown in the second figure, indicates differences in a traditionally taught course, lecture-based, versus a mixed pedagogy, which is kind of like where we started from in a partially flipped classroom, to a non-traditional pedagogy. And you can see the dramatic increase in student motivation with a non-traditional pedagogy. So what do I mean when I say self-determination theory? It really is a theory that focuses on a range of student motivations along a continuum. Everything from A motivation, completely not motivated, to different factors of external things that might motivate students to engage in learning, to fully intrinsically motivated or self-determined, which is what that term means in the theory. And I think, right, these are lovely jargony education words. What do they mean for folks who are teaching? Well, you might hear a student who's A-motivated say something like, whatever, I don't really care. Students who are externally regulated often ask questions like, will this be on the test, right? That external assessment is a thing that motivates them to ask questions about why they should be learning. Introjected regulation is somewhat external, right? So it's motivated somewhat internally, but more so on social interactions. So students might think, I better do this, or they'll think I'm a slacker. In identified regulations, which starts to move towards that internal motivation state, they start to say something like, I'm the kind of person who does the work and does it well, and they take pride in that internalized state of identity and how that projects who they are in the classroom and in the world. As we move closer to self-determined students, integrated regulation, students might say something like, well, I really need to learn this to achieve my goal. So it's much more internal to what I want to achieve in the long run, rather than just who I am and how others perceive me. And finally, when we get to self-determined students, right, they're really often who we were as students, I think, as academics, right? They say things like, the learning objectives are important to me. I really am excited about learning this content. And it's a piece that matters just for the sake of learning. Students who range along this continuum can be successful. I think the goal, and I'm thinking about a lot of this motivation theory, is how do we move students along from a motivation or very external motivation to more internal motivation. And there are three components that contribute to that. So students' competence, or their beliefs about their ability to succeed in the course and to do well. That's a huge component of just believing you can do well, actually turns out to have motivating and practical behavioral outcomes. Relatedness, or being connected to others in the course, both the instructor and peers, and autonomy, feeling like you have some control over the decision-making about learning. And it's when the three of these things are interacted upon or work together that we start to see students becoming self-determined, or moving along that continuum from less motivated or more extrinsically motivated to more intrinsically motivated. So we use these three ideas to say, what can we do to change the class? And so what we did, we changed the class from 3 50-minute classes a week, plus a recitation where the students would meet with a graduate student and work through a problem, to 2 110-minute class sessions. And really that was taking 2 50-minute blocks, which is our normal Monday, Wednesday, Friday class, shoving them together, and then the class change time in between, we actually recovered as well. We still used the pre-course videos that were developed. They were, I think, hugely instrumental in allowing students to learn some of the very core key concepts before showing up to class. But we engaged that student-centered pedagogy or teaching, and focused on ways to increase competence, autonomy, and relatedness. So we really worked to limit our instruction to 30 minutes at the beginning of that 110-minute period. We radically rethought, okay, what do they need to know? What's essential versus what is just building on what we already said and things that you could learn through doing. We put students in homework teams where we actually gave the team the grade for the homework, which was also, again, there was a bit of pushback from some of the faculty about, are they actually individually learning? But what we also did was we increased the number of homework assignments each week by 2 questions. And those 2 questions we engaged in the classroom space. So we gave the 30 minutes of direct instruction and we said, all right, now you get a chance to work on your homework in teams. Let's start with this problem. All right, read it out loud. Step 1, go draw the process flow diagram. We'll come back together if you get stuck and make sure that's drawn correctly before you start doing problem solving. And so we created basically a space where there was a guided inquiry model where we as instructors were not the people demonstrating problem solving as the knowledgeable expert at the front of the room. We were allowing students to engage with one another in hitting the bumps they would hit often outside of class doing homework in class, and then guiding them when we saw that they were getting stuck, either individually in their teams, or if we saw kind of collectively the class was all having a problem, pulling them all back and saying, let's take a look at this. Everyone seems to be struggling. We also changed the course language to promote relatedness and to engage students a little bit more. So we changed office hours to help hours. It's a minor change, but we saw an increase in student uptake in showing up in those sessions to talk to us and to get help. And then we also shifted our language from lectures to discussions because we wanted to kind of center more of that back and forth engagement rather than someone talking at the front of the room the whole time. And so we asked 3 questions. Did students perform better when we made these changes? Did their motivation in autonomy, relatedness, and competence change during the semester? And does that motivation predict their success, particularly compared to when we taught the course previously to when we taught it again the following year? And we did that to reduce some of the instructor level effects that could have occurred if we looked at all those sections. So what did we find? Well, we found here that compared to the historic DFW rate and our not so great replication of that in 2018, the rate dropped dramatically in spring of 2019 when we implemented these changes. In the follow-on semester, when a different instructor was teaching the course, we saw a similar low rate of change here. I will note statistical testing indicates no significant differences between spring of 2018 and spring of 2019. I think that's an underpowered test. When I look at the power for that test, it's only about 27%. And so the plan was pre-COVID, we'll just keep tracking this over time and then be able to compare if this is something that's consistent and not likely occurring due to chance. Of course, COVID happened, and we'll talk about study 2 in a minute. But we also asked about student motivation. And what we found was that there were no significant differences at the beginning of the semester and the end of the semester in the course, which we're like, oh, so we didn't have any effect on motivation. What we actually saw, though, was that the distribution of motivation tightened up. So students who are at the tail end, who were the least motivated in the areas of autonomy, relatedness, and competence, they moved up much more dramatically. And so there were changes, but not in the average value in the course. So we said, well, maybe there's something there. Maybe there's something about the change in motivation over time that might predict student success. So we used a linear regression model here to look at the effects of a couple of different things, mainly the changes in motivation, delta autonomy, delta relatedness, and delta competence over time, and predicted students' final grade in the course. We controlled for the prior academic performance in the before they showed up to the class, their GPA. And we also included a fixed effect of the term that we were offering to control for the students in the sample and to distinguish between those 2 groups. And what we saw out of the 3 motivation constructs was that the change in competence seemed to be the thing that was most important for students who were more successful. So a 1 change increase on a 5-point scale in competence indicated a likely increase in the student's final GPA on a 4-point scale of 0.6. So almost half a GPA point, or about a letter grade, half a letter grade increase in the outcomes for the class. But we also looked, were these changes in motivation different by the terms? And we looked at the interaction effect there. And what we found, again, was that the change in competence seemed to be even bigger from start to finish in spring of 2019 than the spring 2018 term. And so if we look at that, we say that when students had the same 1 level increase and they were in the spring 2019 term, the redesign course, compared to a 1 unit increase and were in the spring 2018 term, we saw an increase in their GPA of about an entire grade point, or a whole letter grade for us, moving from a B to an A, or a C to a B, or moving from that failing D to a C. So we said, there's something here. Competence seems to be the thing, and this redesign course seems to be successfully targeting that piece. So why do we think that is? Well, we hypothesized that students felt increased competence for 2 reasons. They had more time to grapple with the difficult problems in class when they were supported by other students, and they saw others get stuck just like them, and that normalized that struggle and didn't make them feel isolated or alone in their efforts. And I think this is really important, right? Because motivation is not just, are students learning, are they engaged? It's linked to a lot of other outcomes we care about: retention, academic success, and belonging. And we have plans to continue to focus on these beliefs about ability to succeed, and even more openly discussing in the classroom to try to promote changes there. And I'll end this study with the quote from Bandura that says, people's level of motivation, affective states, those internal emotional states, and actions are based more on what they believe than what is objectively the case. And so by targeting their beliefs about their ability to succeed, we can have significant impact on their outcomes. I'll briefly go through study 2 because I know we're running short on time, and I want to leave plenty of time for conversation and discussion. But the plans to continue this work got a little bit disrupted as we shifted to emergency online teaching in spring of 2020, and then rolled out an asynchronous version of this course online in the fall. So students, again, watched pre-recorded videos. They still did homework in groups, but they met virtually around their schedules, particularly when we have international students who are joining from all over the globe, engaging in the course. And one of the new implementations this semester was an online homework platform that gave automatic and rapid feedback to students. So without the interaction and guided inquiry in the class, we had to rethink what that might look like. There were synchronous sections for help as well as tutorials, so showing how problem solving happens and walking them through the approaches to problem solving that they would use in the class. And then there were additional videos provided to students. And so we asked 2 questions about this fall semester. We continued looking at motivation, and we wanted to understand, how does the motivation potentially change, and how is it linked to success in this current context, which is really different than all of the intentional changes we made previously? And does that effect vary by race or gender? And particularly because in the United States, we've got I think the conversation around the racial reckoning that's going on in our context, as well as the disparities in access to online learning tools by socioeconomic status within the United States. And then we were interested in gender identity as well, as students and women in particular had those higher rates of change of degree. And we worried that this switch to online might have an effect there. And then we also measured or added to this stress. We wanted to understand about student stress and the engagement in the academic learning environment. So what did we see? Well, we saw significant changes in motivation this semester compared to the previous ones where we didn't see any significant changes in the average values. We didn't see any changes in relatedness. We hypothesized students didn't expect to be super connected to their peers, and perhaps they weren't. Autonomy went down over the semester, and competence went down as well. And it had an interesting shift in kind of flattening this distribution over time. We looked at predicting students' academic performance in the course again, using a linear regression. Again, we controlled for prior academic performance. And then this time we were also controlled for race and gender. We did find that students who identified as Black or Hispanic or Latinx or Indigenous were less likely to perform as well in the course as their peers. We did see no gender differences there. And then we looked at the changes in autonomy and competence, and those seemed to be the ones that had significant shifts over the course of the semester. We saw no significant differences there. But interestingly, when we added in the interaction effects of both race and gender with motivation, the only one that was significant was students who identified as women and who had positive changes in their competence beliefs actually were less likely to do well in the course. And that started to get our heads scratching what's going on there. So I plotted it out here for you. We see that students who had almost a 2-unit change in their 5-point scale for competence did worse in the course, which is really concerning. The overlap on the upper end of that is non-significant, but we see a big change in students who had the most positive changes in their beliefs over time, having the worst outcomes in the class by almost 7 grade points out of 100. Everyone went down in motivation, but we also saw that women overall went down more. So this is a smaller group out of the larger collective. I'll talk more about maybe why we think that is. The other question we asked was about stress, and we measured that using a depression, anxiety, stress scale that's really commonly used in psychology. And we did this path analysis or structured regression of how stress predicted their autonomy and competence at the end of the course and how that predicted their final grade. Again, we saw really weird effects of competence, increases in competence predicting lower success in the course. Increases in autonomy did predict final grade as a positive predictor. And then of course, stress reduced motivation even more. So that negative 0.314 and negative 0.250, that caused even lower motivation for students. And so students who were more stressed most likely had negative shifts in competence, and that actually indicated they did better. But if they had positive changes in competence, they did worse. So what's going on there? We also asked students about what were the sources of their highest stress. And what we found was that the highest stress things, the highest ranks, were things that they normally talk about prior to COVID. Exams, final grades, weekly homework, worrying about their GPA. The COVID-related issues came out as a medium stressor. And low stress things were help hours or the learning management system or communicating with the instructor. A lot of the online course shifts were kind of falling into the middle range of sources of stress for students. So what does this mean? We're starting to think through what does it mean. We felt like the self-directed nature of online learning might be a particular challenge for students. So they may feel less connected to the course, others in the course are unable to maintain the course expectations. The other thing is that really this was probably the first time many of these students had engaged in a fully asynchronous online course. So when to go get resources and how to get resources, how to engage with them seemed to be something that might be contributing here. Increasing self-directed learning is helpful. It links to lower stress and more positive outcomes. So that might be a space we need to think about as we think about the online offering of this class. We did see those gender differences. Engagement with the materials, more engagement, higher engagement, which would have caused increased levels of competence beliefs, may have led to overwhelm and inability to succeed in the course expectations and outcomes. There's a documented Dunning-Kruger effect in STEM where men often overestimate their abilities compared to women, but we saw this effect for women in particular amongst themselves. And so some of the emerging literature around this indicates that when your sense of self is highly tied to the success outcomes that you desire. So like, I really see chemical engineering as important to me and I want to succeed, which we hypothesize these women may have been feeling. There's often an overestimation effect, right? It's this like self-preservation mechanism that I'm gonna think I'm doing better than I am because it's so important to my sense of self or who I am. So what do we think we're gonna do differently next time? Well, I think one of the things was giving scaffolded engagement by week. So trying to tell them where to go when to help support that self-directed learning, giving them more formative rather than summative feedback, to help them notice when they're not succeeding without giving a final grade and allowing them to revisit those things maybe multiple times until they reach the level of competency we expect them to get. and creating stronger community support within the classroom and opportunities for them to engage with their peers. We're short on time, so I'll wrap us up, but we're working on developing a future suite of resources. And these are some pictures from the resources we're developing to try to create some of these scaffolding opportunities. So helping them scaffold, do you understand and engage with the learning objectives? Do you have a way to approach problems when you get stuck? And trying to give some visual representations to supplement our written textbook. And I'll stop on this slide. My advice for considering course design, begin with an educational framework. It was super helpful for us to be able to start from somewhere and think about what changes should be made. Don't just focus on what you teach, but how you teach it. That seems to be just as important or even more important when we look at the success of our motivation and interventions versus the impact content redevelopment. Start small. Think about being active, blending online and in person, and collaborative, creating opportunities for students to engage amongst themselves and away from you as the instructor. And then lastly, I'll kind of say this might seem overwhelming. So consider a Swiss cheese model of change where you eat out the pockets or the holes in the cheese where you have the opportunities. Eventually over time, as you do small efforts over different periods, eventually you'll get rid of the cheese, right? Or maybe the problematic blocks in your own teaching, but it doesn't all have to be done at once. So thank you for inviting me. This has been a lot of fun thinking about the development over time, and I want to make sure we have a little bit of time for talking and asking questions.
Allison, thanks ever so much for such an interesting and thought-provoking talk. It was really fascinating. I think Nilay's just put a question in, but could I just ask one before I move to the chat-based questions? So you mentioned, I think, on about slide 30 that you had some feedback from the students themselves, right? So what kind of questions do you ask them about, course enjoyment, lecturers, things like that?
Absolutely. So we have our traditional course evaluations, right? So we have those written comments every semester to think about the student voice. This was in addition to that. So we asked them about stress. We asked them what sources were the highest contributors. And then we had some open-ended responses, which I didn't present here. And we're in the process of analyzing questions like, how has COVID-19 and the switch to online learning affected you? And we left that really open-ended, and we got a really wide range of responses. We got things that were related to technical course issues and content challenges, but we also got a lot of like well-being type comments as well about how stressed out students were, how isolated they felt, a lot of other things that are going on in the student experience right now that are really concerning and need some careful attention beyond just all the things we're working on in the online space to make teaching great and translating content there. I think a broader consideration is the thing we're starting to think about, like, what do we do differently to support students beyond just learning the content? And those open-ended feedback pieces are, I think, really helpful when students are able to put their voices into that survey and feel like they have a change in the course. And I think one of the other things that's been really effective is we've summarized the feedback. So we said, like, we heard from you, and here's what we heard on generally speaking, like, these are some of the good things, these are some of the bad things, here's what we're doing to make change. And that also, I think, has a really positive impact on things like autonomy, that students feel like their decisions or their voice matter in the process of doing the teaching. And sometimes the answer is, I hear this and I can't change this now, but I appreciate it and I'll think about it for future courses. And some of it is, I hear this and I can do this right now and I'm going to change it in this way. And we have to be flexible this past fall and this spring in what we're doing because of all of that context.
Thank you. I mean, I'm not actually surprised to learn that getting students to work together so that they can see that, all the other students don't all know the answer. It's just you who doesn't know the answer. And to change, for example, office hours to help hours, because there is this, I guess could be some mentality that office hours are for when you're so smart and you've understood all the content and you want just to have some verbal jousting with the lecturer, whereas if you call it help hours, makes it okay that you actually need help, that it's okay to need help, hence you go and you say, I don't understand, you know, and that makes a difference, that people are less scared to sort of address issues with understanding early on, rather than when you get to the the end of the semester or the end of the year and you're so overwhelmed that you're just, well, I'm just going to quit. I think, right, I don't want to hog this discussion. I think I want to propose actually to go through the questions in order, and actually I can read the questions out, but I can also call it the person who wanted to ask, and maybe we can have a discussion. So Nile, your question was first. Do you want to unmute and ask the question yourself, or I can read it out if you like? Okay, Nile, I've unmuted you if you want.
Oh, thanks. Sorry, I wasn't sure how to unmute. Yeah, thanks. That was really interesting. I don't know if you've read my question, but one of the challenges we have, and actually it applies very well to material and energy balances, is there's a danger of our students learning what I call recipe-based problem solving. Right. So they see a flow sheet with a recycle. They say, oh, if it's got a recycle, I'll do this. If it's got a purge, I'll do that. So they develop this recipe-based approach, which unfortunately in high school maths, they've already started to get used to. What we want them to do, of course, is to fall back on the fundamental engineering principles and to use those as their way of navigating an engineering program and solving engineering problems. And I was curious if you've got this concern of this recipe-based approach, and if so, how you avoid it.
I definitely do. This has been a depth conversation between Brian and I. You know, I think what you're identifying is a phenomenon that happens across STEM. There's a really great body of literature in physics around surface features in problem solving, and like how students glom onto like, oh, this is a ball rolling down an inclined plane. Like these are the equations I have to use, and not really understanding the fundamental concepts and principles that guide those problem solving decisions and how they approach problems. I feel like historically in this class, we've had to break those down, or they do break down, and the students who rely on those problem solving approaches often do worse in the class. And so my question is always, well, how do we shift that, or how do we help support that better? One of the things we've been doing, I'll go back a slide, is we've actually been providing not a recipe, but a mnemonic to help students think about where to start and where to get unstuck when they start solving problems. We're calling it PKs, for lack of a better thing that we could come up with as something you could pronounce, but it's shown here on the right. And we're basically asking them to break down a problem through first drawing a picture, labeling the unknowns and unknowns from the problem statement, writing down their assumptions, and then figure out where to start from either a degree of freedom analysis or something else, like writing down the materials balance governing equation. And then, you know, think through what are the pieces they need from first principles rather than from a problem solving algorithm based on the surface features to start the problem, solve and check their answer. And so I think this approach is valuable because it still gives some students a bit of a safety blanket, like a thing to hold on to. But it moves away from saying, oh, this is a recycle problem, or this is a problem with a heater or an impeller, to, okay, every time I'm going to draw the diagram, I'm going to identify what I know and don't know. I'm going to start from, you know, accumulation equals in minus out plus generation minus consumption, and simplify from there. And it creates, I think, a framework that goes back to the way we would solve a problem as the expert and helps demystify that a little bit. So I don't know, I hope that answers at least some.
Yeah, great. I like this framework a lot because they need some structure.
They need something because they do get stuck and they panic, especially on exams.
Mm-hmm. Yeah. Thanks.
Absolutely.
Thanks. Marsha, would you like to ask your question? I've unmuted you.
Thank you, Anna. Many thanks for sharing your work, Allison. I found it to be very interesting. I was just wondering about the extent of the student involvement during the module Redesign, and how their feedback might have been used prior to the implementation of the module itself?
Yeah, so we have done a couple of things. I think one is just like I spoke to, we just have historic feedback on like what seems to work and doesn't seem to work through course evaluations. But in the motivation pieces, we based a lot of our changes on what we do in our first year engineering experience, and the feedback that we got from students in a prior course to changes in this course. And then we of course, through assessing these pre-post measures quantitatively, but also in the open responses, like evaluated what the effects were on students. As we're implementing these resources, that's a space where we're, I think, being more proactive about engaging the students at the front end. We are in the process of conducting some focus groups now with students about how effective they think these resources will be, what's missing, what they wish they had had while taking the course, and for students who are currently in the course, like how effective these pieces are for their support. And that's been really insightful because it's caused some shifts and change to the organization of the resources, as well as the focus on visualization, which is kind of pictured here in the center, to help students understand some of the key concepts they're not getting out of just reading the textbook or the examples that are given there. But I think it's an ongoing dialogue. Like it has to continue to be a back and forth because they're the ones who are the recipients of the changes we're making. And that voice matters, particularly in the space of autonomy, right? Like that they feel like they have power over their education paths.
I agree.
Okay, thanks, Marsha. Thanks, Allison. Right, Salva, would you like to ask a question?
Yeah, I was wondering how you ensure that the students watch the videos in advance and that they later turn up to the group discussions.
So we don't have a mechanism that we're giving like credit for videos. You know, and this is always the sticky part of doing partially flipped classrooms. The best, like I would say generally, right, the uptake in watching the videos prior to class is a good proportion, probably 75 to 80%. And we can track that through our learning management system. We set the expectation from day one that like this is expected. And then I think the other piece that I think has helped with such a high uptake rate is like, we just assume they have. And so we don't rehash the videos. We start from where the video is left off. And I think the students who think, oh, I don't need to watch that, they pretty quickly learn they need to watch it in order to be up to speed in the classroom space when we do those shorter 30-minute lectures at the front half of the class. As far as students showing up and working with their peers, I think the incentive that we've given of you get the answers to 2 of your homework problems a week in each of the periods that we meet together has been hugely motivational. You know, I think in prior classes where it was very lecture based or just problem solving, you know, modeling for the students as the instructor worked through the problem, we probably had, I don't know, 10 attendance, maybe less.
Yeah.
And when we started saying, hey, you're getting answers to your homework by working with other people in the class, they started showing up at much higher rates, like 75% at a very early class for our students, I think 8:30 a.m. And, you know, it's funny because we didn't actually have them do any fewer problems outside of class. They were doing 5 problems outside of class. We just added 2 more problems and did them in class. And that was a hugely motivational change.
Mm-hmm. Okay,
But
thank you. Yeah. Yeah, this works if you have the assessment before the exam that counts for the final grades.
Right. We do have the structure of multiple exams during the semester,
Yeah.
than one at the end.
Thank you. Yeah.
think we have one more question, but actually on the topic that you just discussed, I mean, feedback is an extremely important thing. But one of the things that I personally kind of observed and found tricky, no matter how you look at it, is that, for example, for any given assignment or exam, you know, the grades have to have the shape that centers around a particular grade, right? And the same for coursework. And this means that, you know, even if the person has literally done everything they could have possibly been expected to do, you know, they still don't get 100%. They get, I don't know, 80 or even less than that. And I guess because the other students are maybe provided answers that weren't quite as complete, they get even less. And then you're pushed into 60%, you know, and it's not always clear, I don't think, to students why they got that particular grade, because if you got something like 65%, well, does it mean that you've not understood 35% of the course? So I think maybe somehow I need to kind of address that. Right. Question from Ahmed. So Ahmed, would you like to ask your question?
Yes. Can you hear me?
Yeah.
Yeah. Thank you for the great talk. I was just curious about the relationship of gender identity and ethnicity on how motivation predicts student performance. I think you mentioned some surprising findings, but then I had some issues with the connection, so I'm not sure if you've already covered that.
Sure. So, yeah, I think, so one of the things I'll say, unfortunately, I'm not very surprised by the main effects for race ethnicity in our context. And it's an issue that needs to be addressed. Students admitted are all equally likely of success. But I think there are particular kinds of challenges in the learning environment in a predominantly white institution that create spaces that aren't as inclusive as they could be, and don't necessarily have the larger supports for students that are necessary for success. So it's not the students, it's the system. We have some great programs on campus that are working towards that, particularly our minority and engineering program. But I think there's also this reality that often the professor, the instructor of the course can be a huge help, and engaging students in that help sometimes is challenging because the professor's perceived as this highly distant, highly powerful entity that you don't go to, right, immediately for anything. You go as a last resort. And some of the conversations that I've had with students on a one-on-one basis have been particularly enlightening in that space, and create, I think, some opportunities for us to A, be proactive and reach out, and B, demystify the process a little bit, the system, what folks often call the Null Curriculum, like the things we don't say, but we expect students to do to be successful. The one example I have is a student who was in my class and like, I mean, just super bright and asked great questions and bombed the first exam. We did terribly. And I emailed him and I was like, hey, like what happened? I know like you really want to succeed, and this is not what you probably hoped was the outcome. If you want to talk, come talk to me. And so he came and talked to me, and the conversation was around like, how are you studying? Like, what are you doing? And he's like, well, I'm just working all the homework problems and reading my notes. And I was like, okay, well, like that's a good start, but that's a lot. And that's a lot of things to start with. I said, you know, have you started by going back to the learning objectives and looking at like, what are we going to be assessing? Because that's how I start to write the exam. I look at what I said I was going to assess, and I write the questions to assess that. And he's like, oh, and it was completely shocking to him that that's where he should start the process of learning. He completely changed his study strategy, and the second exam was one of the top scores. And all it took was demystifying that process for him. Probably conversations that a lot of his white peers were having on a regular basis, but he wasn't privy to or didn't understand or know. That proactive piece helped with that. The gender piece is really interesting. And I really think that the explanation that this might be a particularly important self-preservation mechanism is why we see these changes. So overall, women generally decreased in competence just like everybody else and did no different than their male peers in the class, the average scores. But what we did find was, right, women who had the highest changes in their competence beliefs did the worst out of everybody. And the literature on kind of self-response bias indicates that like when that outcome, doing really well in a course, is super and personally important to you, you may be much more likely to overestimate your abilities. And I think the students who had those, you know, who cared a lot, overestimated their abilities and maybe didn't either work to understand the material in the same way as their peers, or felt overconfident and worked as hard as they thought they had to and then didn't do as well. And so to me, it's a bit of you're missing the norming process in the online classroom environment for students to gauge where they're at, and providing some more formative feedback like check-ins and ways for them to see, okay, do I really understand this? Am I really doing as well as I think I am? Providing more of those before, you know, summative big exam type experiences can also help.
Thank you so much. That was great. Thank you.
Thanks, Ahmed. Thanks, Allison. Vijesh, you're up. If you'd like to ask in person.
Yeah, thank you, Allison. I would like to ask a few questions, and just not in any sequence. But one of the things that I have seen with students, I'm not sure if that happens with content overload, especially after the COVID, where there are just too many videos, not just from one course, but when all of the courses are doing flipped, for example. Do you see kind of like a potential drawback when everything moves to the flipped, for example? Which was one question. And the second one was regarding the online assessment with immediate feedback that you mentioned. Was that more on the MCQ styles, or was it something which was math aware, where students could actually enter in equations and etc.?
Yeah, these are both great questions. I think the content overload is totally an issue, generally speaking, with materials and energy balances, and then also even more so in online. You know, again, one of the other pieces we talked about, right, over and over again in the instructional team for this project is that sophomore slump, and like the reality that this is the like first time students are engaging with chemical engineering, language, jargon, problem solving approaches. The course is so fundamental to success in every subsequent course because it's like the foundational base for separations and you know, fluids and a whole bunch of other things. And then the just like content load of a 4-credit course, right? All of that plays into, I think, why this course has historically been such a challenge for students. But when we shifted to online, I think we saw that even more exacerbated of students didn't know, like when the instructors in the classroom, they could say like, okay, this is what we're focusing on today. Let me point out the highlights in my lecture. Okay, next you need to go do this homework problem and work together, and it's guided or instructed. And then they say, okay, for next class, right, watch these videos and we'll talk about topic X, read this section of the textbook. And I think students needed a little more scaffolding when we did the online. Like there was weekly planning and like instructions on what to do by week, but it wasn't laid out collectively for the semester. And we just switched to a new learning management system in fall of 2020 on top of everything. And so I think there's opportunities to engage a more structured approach to say like, today do these things, or, you know, before the next class do these things, and provide some kind of scaffolding for students in that space to help with the overwhelm. Because many of them reported like, I open the learning management system and it's just like a wall of videos and a wall of you know, assignments and things to do. They just needed more structure and support in that space. Your second question was, I'll pull it, oh, the system. So we're using the complementary online system to our textbook. So it's Wiley Plus. And I think it has a range of different things like inputting actual like values from the problem solving. So like what's the flow rate of stream 2, but also, you know, formulas are allowable as well. It depends on the question type, but it is linked to the textbook and the problems associated with that.
Okay. Mm-hmm. Thank you.
Thank you. Right. I have a question which I will read out from the chat. Asking, did you see any change in the performance of underrepresented identities pre-pandemic and now?
So we did the analysis prior to the pandemic in the spring 2019, 2018 data. We saw no differences in the average course performance for women and for underrepresented racial and ethnic minority students. We did see some changes post-pandemic. So we are seeing something there. On average, women didn't perform any differently. We did see something in the space for race, ethnicity. I think there's like a couple pieces there that I do think the pandemic has had an impact. Particularly when I talked about like the context, right? And when students are off campus or like not able to be in the classroom, they may even be at a higher disadvantage for not understanding the unwritten or unspoken expectations for learning, but they also don't have direct access to a lot of the support services that they normally have access to and their peers for mentoring and engagement and things like that. Our numbers are really small though, right? So it's to me, an individual case-by-case basis, because literally I think our enrollment for Black students at Purdue is like 3%. It's really low. And so I think the pandemic has exacerbated some of that, but I also know that this is a really small number, and that's a systematic issue that needs attention. And we've been advocating for that at my department level to the college and university.
Yeah, and it's a whole separate discussion, isn't it? It's a very complicated issue, right? I think we've got time for just one more question. Pavani, I've unmuted you if you'd like to ask.
Yes, please.
Go ahead.
Thank you so much for the informative presentation.
Thank you for having me.
And my question is like, I was never a good student in the classroom. That is mainly because like the content was way too much and there were too many memory tests that I had to take throughout the semester, which was very difficult. At the same time, if I go through the content, I would take like only 2 or 3 sections from entire curriculum and go deeper into it, then I gain a lot more insights, and it helped me develop creative problem solving skills. So now that I'm moving towards teaching, how would I like balance these two approaches? Because the first one is a lot more students are more comfortable with in getting the grades, but at the same time for engineers, creative problem skills are a lot more important.
Yeah, it's a great question, and one I think it's a constant balance, because I think, right, as an instructor of some of the introductory courses for students, I always feel this responsibility of what do the instructors in subsequent courses expect students to know, and am I setting them up for success, not just for my class, but long term. And so there is a bit of like, there's a set of things I need to make sure that we include in the class. And then there's other things, right? Like when we did this redesign originally, there were things in the class around like, you know, reaction coefficients and equilibrium and solid state solution type stuff. And it was like, these are nice to know, but not essential to know. And because we were trying to create space for more student guided inquiry, like we just said, you know what, because it's not necessary, we're going to take it out. And that's, you know, painful to reconsider the canon, but it's important if you start to think about creating space for this. You know, I think the question around the deep learning, I think it has two parts for me. One is working on resetting students' expectations from grades to moving them up that motivation scale or learning more from a self-determined perspective. I think when students stop focusing on the grades and more focus on the learning, they engage more deeply and they end up with better outcomes on the grades too. And so there's sometimes some very frank conversations we have about like, yeah, the grades are nice, but they're not the be all end all. And really this is where you should be focusing, is understanding this so that as a chemical engineer, you can be successful in your future classes and in your future career. I think there's a piece of connecting what they're doing to that bigger picture on a regular basis, because often they can't see where this is going through the weeds. And so we pretty regularly say, okay, like we're going to start talking about this, but this is connected to this future class and this future class. And then we, you know, when we have time, tell stories about how we've used this concept when we were doing research or practicing as an engineer, or those kinds of things, to try to create that more internal motivation for students, or at least that integrated regulation where like this matters for my future career. And then I think lastly, right, there's a bit of, when you're trying to balance all of that, creating the opportunity for students who are excited, who are succeeding, to dig deeper. We always provide additional problems that are not on the homework, that are not on the exam, that students who want practice or want to engage more deeply can do. And we provide tutorial solutions for those so that they can spend more time if they want to spend more time on those and learn more. But some students are just trying to get by, and I get that too. So we don't assign them as required problems.
That makes sense. Thank you. Thank you for the ideas.
Okay, thank you, everyone. I think we're just a few minutes over time, and Allison will need a bit of a break before she chats to various people in the department. But Allison, thank you so much for taking the time to join us today.
Thank you so much for having me.
For sharing your thoughts and findings on this really important topic. So thank you very much from all of us.
Thank you. And I look forward to future conversations and appreciate the opportunity to talk a little bit about this work.
That would be wonderful. Thank you. Thanks so much.